So, okay. Thank you for the opportunity. Hello, everyone. My name is Luis, and I, along with Charles and Maxim, will be presenting the topic of security in software design. Disclaimer: security is a broad term. We try to narrow it down as much as we could and kind of focus in one specific area. And also, one of the questions that you want to pose yourself and try to answer maybe on your own is like, what is the purpose of the internet? So, without further ado, I'm going to share my screen and start with concepts first. So here we go. Can you all see my screen? All right. So here's an introduction. So the purpose of a network is to move information from one location to another based on knowing where it needs to go. Using first principles, we can expand on this concept. As you can see in this picture here, figure 1, we have three main components, a container, a mechanical arm, and then another container. The purpose of these components is literally to move information or data from one end to the other. This sample illustrates the definition of a network very clearly, which is moving the contents of a container A to container B indefinitely or until A is empty. In example 2, the concept remains similar, but now containers A and B are separated by some distance. We require a medium through which data can travel from A to B. The conveyor belt illustrates this perfectly. And in the network analogy, we can think of this as Ethernet or fiber optics. And to stretch it, we can think about it even maybe wireless connection. You can also see a bit of congestion here happening on the receiving B, which can be due to bandwidth limitations or hardware constraints. Again, this perfectly illustrates how some devices are limited and that speed is relative, with data transferring only as fast as the weakest links allow. So in example 3, due to even more distance, a third container is added right in the middle. The objective remains the same, move data from one location to another, in this case from A to B and from B to C. And now that we have these principles clarified and we know what a network does, let's imagine that these boxes sort of represent switches in a network. And now we kind of expand on the thing even more. In example 4, we have a model and we analyze the anatomy of a switch or a device in a network. On the left side, we have some logic. And on the right-hand side, we have containers and blue servos tethered to the logic components on the left. These containers and servos are moving packets as fast as they can according to instructions from the logic components. Switch B is performing the same operations but in reverse, meaning it is receiving data. Notice that the packets are all different colors, representing different networks or maybe VLANs. And I'm using those terms interchangeably here because they're different layers, obviously. Again, the original claim still stands. The purpose of a network is to move information from one location to another based on knowing where it needs to go. So in example 5, we take this example a step further and separate the logic components from the hardware components. We separate the muscles from the brain and isolate them. Furthermore, the medium between switch A and B is able to multiplex, allowing it to send and receive traffic simultaneously. So now we have a switch A and switch B interchanging data between the two locations. So now we're going to introduce SDN and also just letting you know that these things are actually doing some logic behind the scenes. It's not very complex, but it's just kind of like to make it work. So now that we explained the purpose of a traditional network and its components, I'd like to introduce you to the two main components of software-defined network, which is the control plane on the left side and then the data plane. In SDN, the control plane functions as the brains of the network. It stores critical information about the network state, including routing tables and the overall topology. This plane is responsible for making decisions on how data packets should be routed through the network. By maintaining a global view, the control plane can optimize traffic flow, implement policies, and quickly adapt changes to failures. It communicates these decisions to the data plane. On the other hand, the data plane acts as the muscles of the network. It rapidly forwards packets based on rules established by the control plane, ensuring data moves efficiently along designated paths. This separation of roles allows a more flexible and efficient network management compared to the traditional architectures. And now we're going to put this further together. And this is what perhaps a network would look like, a software design network. So we have the control plane. We have 3 control planes communicating with each other, exchanging information about the state of the network. Having multiple controllers makes the SDN scalable, as we've learned in the previous classes, and resilient. Removing all the controllers would introduce instability, but functionally, the network would continue to work since the data plane devices still hold forwarding information, although it would become stale over time. Furthermore, updating the devices would not be possible without the controllers. The controllers are connected to every single SDN device via yellow cables, as we see here. This is, again, a concept. The SDN-enabled devices are receiving updated forwarding information and ready to adapt to any changes that might occur in the network. As you can see, separating concerns allows for maximum flexibility in software-defined networks. By abstracting the hardware layer, SDN aims to enable vendor-agnostic interoperability between different hardware vendors. For example, it's possible to have devices from Cisco, Arista, Jupiter, and others operating within the same environment using common SDN protocols like OpenFlow. The control plane tells each device what to do, while the SDN-enabled devices forward packets and update their tables as directed by the controller. This vendor-agnostic approach can allow for a unified and flexible network, regardless of underlying hardware. However, practical implementation depends on the level of support and compatibility provided by each vendor. Achieving seamless integration across different vendors may require a careful selection of devices that support common protocols and standards, and attention to specific device capabilities and protocol versions. So right now, I'm going to show you basically what we've created. This is the topology. It's in the paper that we wrote as well. So here we have Spectrum and Google Fiber and the overall internet. We are using UniFi as the SDN. SDN is a term sometimes used, it's very markety. So different people will tell you different things. In this case, UniFi has their own SDN. And as you can see here, we have a home network and then an office network, and they are connecting to each other. And this is called a site-to-site VPN. And I'm going to show you here basically what the site magic is. Basically, WAN to LAN. So we have WAN office, and then we have different networks. And these networks are able to talk to each other or see each other in essence. Furthermore, here's the topology, for example, of the office. We have a spine and leaf topology. We have the router, the spine, the leaf, and our controller here, which is this thing right here at the bottom, and then a web server. And the controller, as previously explained in the previous example, is basically controls a bunch of things, more than just the routes. It controls hardware updates and so on and so forth. And there's also, I'm also able to see notifications and, threats, triggers, VPNs. It looks like there's some threats here too that, we can look further into. Underneath all of this, underneath the side-to-side VPN, it's WireGuard, which is basically the glue, and it's what is making this work. So I'm going to let Charles basically explain this portion of the presentation, which is now WireGuard.
All right, thank you for that, Luis. So I have a lot going on the screen here, but the first thing I want to talk about is the WireGuard client. Here you can see that I'm attached to Luis's Office VPN. Basically, through a private key, I have the connection allowed here through WireGuard. And just to verify that, I did a what is my IP address here. I am in Northern California. Luis is in North Carolina. And then I just out of curiosity, I ran a speed test so that I could see what kind of loss I was losing. So Luis is on a gigabit Google Fiber. I am on a gigabit near Northern California. And so I lost about 50% of my bandwidth just connecting through his VPN. Now on the top left screen, or the top left Wireshark, or I'm sorry, yeah, Wireshark, I have the internal network traffic that goes between my house and Luis's house. Unencrypted. Every time you see the word desktop, that is my computer. And on the right side, I have the WireGuard outbound traffic showing that full encapsulation is happening through the WireGuard VPN. Now, I noticed Luis stepped away for a second, so I can tell you guys that that was me that was probing his network earlier when he was talking about those threats. So I Nmapped his network when I connected to it, and I found a couple of endpoints. And as I was scrolling through here, I saw this one. It's called Guru-Luis local domain with a .27 address. So I got curious, and I went to that website, and I see that that is the Guru services for an online IT school to learn from the Guru. What I was thinking though is maybe I could hack this network since it is a software-defined network. Maybe there's some vulnerabilities here. Now, unfortunately, I can probe a network, but I'm not the right guy to break into a network. So for this, I need to step out and I'm going to hand it over to a friend of mine who is a hacker and who can do something about this. So let's get my hacker friend online here. You're on mute, hacker friend.
What's up, Luis? Long time no see. How are you?
Luis stepped away, so
Oh, he did?
yeah.
Is
So
that the Guru guy you were telling me about?
that's the Guru guy. I think we should
Yo!
break into his network while he's
Yeah.
away.
Yeah. First of all, Charles, can you see my screen?
Yeah, everything looks
Okay,
good.
that's awesome. So I already cracked his password. That was
Oh,
so
really?
easy. Yeah, you cannot believe how many characters it was.
So, okay, can you get to that website?
Absolutely. Let's see what's going on. Do you see that do not open thing?
Yeah, what is that?
That's something that Guru definitely would put on his main desktop. Okay, let's see what we have. Oh, he left all of the sensitive stuff, like the maps and stuff. So let's see what we can do.
Can you change his website?
Absolutely, I'd love to do that. Let's see. Yeah, so that's an HTML thing for his website, like pretty much the page. Oh, here it is. Guru
Yeah,
services.
leave him a little note there.
Yes. Let's change it.
Oh yeah, he's gonna love that.
You'll definitely love it. Well, let's see how we're looking. Oh, way better, huh?
Nice. Okay, so that's like, child's play, but can we take
Yeah.
down his whole network from here?
Well,
How
Charles,
easy would that be?
that would be pretty easy. That would be pretty easy because it's SDN. So he has only one control plane, I would assume, because since he had like 5 characters password, I think he doesn't have replicated control plane. So what I'm gonna do, I'm just gonna flood him, and we're gonna replace all of the valid rules for the traffic with our stuff. So he pretty much just would lose the control over his network. So let's see how that plays out. Is there anything I can help you with today? Besides,
No, that's it. That's it. I appreciate it.
perfect. You have a good day.
Thank you. Hey, Luis, welcome back. I think
Thank
you're on mute.
you. Thank you. Sorry about that. I have a newborn and have to check on her. Okay. So I'm going to basically show you that, yeah, I have my site here and my control plane again, kind of explain further. Wait a second. My controller is offline. Oh, wow, this is kind of embarrassing. Connection is taking longer. What is going on here? Oh my gosh. Okay. Sorry about this, guys. Sorry, Professor. This is kind of embarrassing. I am the guru after all, and I don't know what's going on. Charles, did you see anything?
No, I was
Connected to
given a
site.
presentation and then I don't know.
It looks like I should have added another controller here. Okay. Oh God, look at this. I can't reach it anymore. So my network's kind of not working right now.
Is there anybody you could call for help?
Yeah, actually, you know what? I know somebody that I can call for help. Hopefully, hopefully he's around right now. And let me see if I can get his information out. All right, can I get some cybersecurity expert, please, online to help me out? This is so embarrassing.
Absolutely, absolutely,
Whoa.
Luis. My name is Maximus. I just took cyber to 10, so I charge 250 an hour. How can I help you today?
Oh man, that inflation. Yes,
Yes, in this economy.
in this economy. Yes, so it looks like my controller is offline and look at this. Look at this disrespect here.
Oh wow. Oh wow. They challenging you, huh? They trying
They
to see if
are.
you really grow. Oh, that's
Yes.
crazy, Luis. Uh, let me share my screen. If you can just stop sharing yours so I can
Yes.
hop on the
Please,
line
please
and see
help
what's
me.
going on. So, can you see my screen?
I do. I see it. Thank you so
Let's
much.
see. Let's see what are we dealing with. So first of all, how they got in. I would assume that your password might just gave up. And
Oh,
how strong of a password do I have? I'm
I
just gonna
think it's pretty
use
strong.
Hydra really quick. So I'm gonna use this tool called Hydra. So it's pretty much gonna try and brute force your password, and we'll see. We'll see how long will it take. And you wanna hope that it takes not too long.
Oh
So
my
again, 250 an
goodness.
hour. But yes, under 15 seconds, and your password is I am Guru. Luis, we can do better than that. We can do better than that.
Oh,
I understand
wow.
you have that
I
ego
am.
of yours, but we gotta keep it checked. So
Okay.
let me log in and let's see what's going on.
Oh
Okay,
no.
okay, you see how easy that was? Okay, Luis, what is that do not open TXT? What's the purpose of it?
I was trying to remind myself or something. I mean, this is so embarrassing
Let's
in front
see.
of everybody.
You see, here it is. It's everything. Keys to the kingdom. And
Oh no.
so
Oh,
pretty much
oh, that message at the end. Oh,
you have an SDN. You have an SDN, which is it's a control plane that takes care of everything, and it's a single point of failure. And what you did not keep it protected. So the whole thing is secure, all of the flow charts, all of that like nice stuff. But again, if your main brain of the network is insecure, that's it. People will believe in your notes and challenging you. So that's pretty much what's going on. Is there anything else I can help you with, Luis?
no, thank you so much,
Okay.
Maximus.
Before I leave, it's gonna ask you a quick question on the screen.
Okay. Oh, okay. I'm doing custom tip here because
Perfect.
things
You
are
have a good
not
day.
working great right now. All right. So thank you everybody for entertaining us and for going through this presentation. So basically what happened there was my network got compromised. And just remember that an IT system administrator or a network engineer, they're not security expert. We're not security expert. I'm not a security expert. I'm not going to claim I am. And one of the things that happens usually when you're configuring a system is, there's human errors, right? You leave things behind. Your password is insecure. The hacker just used Hydra and basically dictionary attacked my server. The other thing is that the root password was also the same as the user password. So the attacker was able to just go ahead and establish a foothold and see everything. The one thing that I mentioned as I was presenting my the UniFi, I saw somebody scanning my network. I saw Charles doing it. However, I brushed it off. And one of the things that happens in the real world is that you get notification fatigue, right? It's just you get so many things happening that you tend to ignore things. If I would have caught that and just kicked Charles off or look further into it, I would have been able to maybe do something about it because UniFi offers you intrusion prevention system and intrusion detection system. So don't forget to look at your notifications, secure your passwords strongly, and remember, be nice to your sysadmins and your IT personnel because they're not security experts. They're going to make mistakes. Also, make sure if you're deploying an SDN that you have controllers, multiple controllers for high availability. And so that this doesn't happen to you where basically I was brought down. The network was functional. It will still work. However, I'm not able to update any of the routings, any of the hardware. I'm not able to do anything. So now imagine if this network was super far away from me. I am pretty much done and I'm unable to do anything about it. And this kind of concludes the presentation. Thank you all so much. Thanks, Charles. Thanks, Max. And thank you for your time.
Yeah, this was quite something. I've never seen so much effort being put into comedy sketch or presentation. I don't know what was this, but thank you guys. I think you should definitely record it. We have the recording. You should cut it out, and if you're okay with it, just put it on YouTube, like as an SDN intro. This was great. Any questions from anyone?
Yeah, please, questions. Don't make it.
I think we're all still stuck.
I was going to ask if you can help me with my project, but that's my
Right.
other question.
Right. Oh God.
Yeah.
Thank you for going back to what the project was about. I was so into like, oh my God. No, what? I forgot.
Yeah, one of the
so good. But thanks for wrapping it up and bringing us back to, okay, now listen, all jokes aside, this is, what's really going on. So that was so good. Seriously.
Thank you. And that's one of the questions I hope he answers about what the internet really is. It's just about exchanging information, right? Just moving things from one end to the other. And whatever technology we stack on top of that, the essential is going to remain the same. We're just moving information from one end to the other. And once we understand that sort of like base concept, then I think we're able to abstract and make things just easy and understandable. But that was kind of like the purpose of this. Again, SDN is extremely complex topic, and it's almost like a PhD type of work. All of us worked into it and looked at it and taking the time to really dive into the security. As a matter of fact, Professor Heisver has a video on SDN from Black Hat 2015, and it's like, yeah, it's super complex topic, but we tried to make sure that we created this and make it digestible and just make it easy to understand.
Actually, do have a quick unrelated project question, but Max, I know it wasn't you. I know it was a really cool hacker, but did he buy a fake mustache for this? Or did you just have one?
No, so in Zoom, you can, if you go to the video, if you go to your camera, and you do the video settings, you can do like all sorts of things. So you can change the backgrounds, and you can do mustaches. Like when we were rehearsing, we were like going kind of crazy. So we decided to just keep the mustache.
That's awesome.
Yeah, you can do different hats and stuff. So it's like
I did not know you could do a fake mustache.
You can do a makeup.
Yeah, I can be a hacker too. Yeah, that's sick. Or I can be in my next class with a mustache, but that's killer. Yeah. Thank you.
So just to kind of recap what was going on, I lost it. I don't know what was going on. So you had this UniFi.
Yeah.
Is that the SDN controller?
Yeah, so UniFi offers you their version of the SDN, as they call it, and you have a controller, basically, that controls your devices. Mm-hmm. And now you can control the routes, do OSPF, BGP. Go ahead, Max.
No, I was just about to tell him. That's why I introduced you as a guru, because I met Luis for the project during our last class, and he gave me a tour at his workplace. So, and they have like that SDN for the warehouse. It's like warehouse, like Amazon warehouse size. And so he controls that, and then it connected to so it's like Raleigh, like which is the city, and it's office downtown Raleigh. It's warehouse on the outskirts of Raleigh, and then it's like his home, and everything is connected. And then that's how he kind of showed me he pretty much introduced me to the SDN, how the UniFi works, and then like all of those flows. And so we picked the topic because like we already kind of have an infrastructure, and plus like Luis knows what's going on.
I see.
So it's
And
like the whole
Yeah.
I don't know
It's
how
a
many
home lab.
Yeah.
It's a lab that I created, and then we had Charles and Max use WireGuard to connect to this network, and then I created the routes and the web server and all of these things so that we could mock up a penetration that happened at the network level, right? And what would happen for like this? There was a honeypot to like the whole thing. So anyway,
yeah, so
again, we had to like really bring it down because we were like going all over the place with this.
yeah, there was some WireGuarding, some kind of VPN going into the network, right? Okay, you're in the network. Then you logged into to one of the servers. Then you found out there's an SDN controller, and then to attack the SDN controller, you created this HPing, or what was it? Some sort of traffic.
Yeah, that was
enough to bring down the controller.
Yeah, there was a HPing traffic. I can post the command in the chat, but it's pretty much like the flooding command. It just sends packets of a fixed size, and it's over like a period of seconds. It overflows the flow charts. I'm not sure if we did like if Luis set it up so it like take less time to overflow just for the presentation sake, but it pretty much overflows the thing, and then you kind of just lose the control.
Mm-hmm. And the controller
there's
is exactly what?
Yeah.
Is it like a Ryu or type of controller that I demoed, or is it UniFi's actual controller?
It's UniFi's proprietary. They don't.
And you managed to DOS UniFi's controller with an HPing?
Yeah, because the controller is basically a computer.
That's crazy.
Yeah. So again, this is like it's basically a tiny Linux machine, and so if it was a bigger, more robust, even then I think it would be more difficult. But there are some ways to avoid having these types of problems, and that UniFi offers you. But this is kind of like the most basic example of if you see a UniFi somewhere, you can and you get into the network, you can probably bring them down.
Yeah.
So,
also, one comment to add here is so Max took his network down, and so Luis can't get into it, but I'm still connected through the VPN into this call. So the network can still run, but Luis can't do anything to change it.
Zane.
Yeah, first, great presentation, guys. That was awesome. I know you were kind of demonstrating the UniFi SDN. So it kind of seemed like there was a network intrusion detection system sort of baked into UniFi. Is that kind of standard across different SDN solutions, like a SIEM or NIDS kind of capability?
Yeah, excellent question. I don't think it's a standard across different SDNs, and this is one of the conflicting points that I had with this topic is if you ask network engineers, they're going to tell you different things. At the very heart, an SDN is for routing, like to create routes, right? So an SDN for UniFi is like, let's add more things to this controller. So if you go online and type, is UniFi an SDN? People will be like, no, yeah, kind of, not really. So the strict definition is it's just for traffic management and how to create routes. That's what SDN is. And network engineers are pretty, hardcore about that, the definitions that they want to discuss. So yeah, hope that answers the question.
Thanks. Yeah, thank you.
Okay.
Cool, thank you. If you have anything to share with other